Hello everyone, I hope you're doing well. So in this video, we're going to discuss the solutions for Codeforces round 827, which was rated for Division 4. And today we're going to discuss all the problems except the F1, right? So the F problem was, I think the problem name was smallest. Yeah, smaller. So we are going to discuss all the problems except this particular problem. And you can find the chapters, the timestamps to all the problems in the description. So let us quickly start with the first question, which is sum. So it says that we have been given three integers a, b, and c, and we have to determine whether one of them is the sum of the other two. So right, this is a very straightforward question, and it's very obvious that if a number among them is the sum of the other two, then it must be the greatest number. So what you can do is you can just take all of them as input and just sort them, and you just compare. After sorting, you can just compare if the first element and the second element, if their sum is equal to the third element or not, right? So this is exactly what I've done in the code. I've taken three integers, right? I sort them. Why I've sorted them? Because if there is a sum, if there is an element which is the sum of the other two, then it must be the greatest element among all, right? That is why I sort all of them, and I just compare if the last element is equal to the sum of the first and the second element, right? If this condition is true, I just print yes, otherwise I print no. So this was the solution to the first question. Now moving on to the second question, which was increasing. So this particular question states that we have been given an array of n positive integers, and we have to determine whether by rearranging the elements we can make the array strictly increasing, or in other words, is it possible to arrange the elements that like a1 is less than a2 and it is less than a3, a4, so on. Right. So it should be strictly increasing. So we can arrange the elements in any order. That like straight away means that we can make every array into a strictly increasing array if there are no repeated elements, right? We just have to check for repetition of elements. If there are no repeated elements, then the answer would be yes in all case. If there is a repeated element, then the answer would be no. So one way to do is to like store all of the values in a map, and you can just check after storing the values in a map, you can just check whether either of the values have a frequency greater than 1. So this is exactly what I've done in the code. So what I do is I create a map and I take all the inputs in a variable a from like I have a loop from 0 to n, and I take the input in the variable a and I increment the frequency of that number. Right. Now at the end I just traverse through the map. If at any point the frequency of any of the characters is greater than 1, I just print no and return right away from here. Otherwise I print yes at the end. So this would be the solution for my second question. Now moving on to the third question for today's contest. So this question was stripes. Now this particular question says that we have been given an 8,8 grid, right? Now it says that like there are some strips that are being painted on the grid, right? Now the blue strips are always painted in a vertical manner and the red strips are always painted in the horizontal manner, right? So we have to tell like whenever, so if you can see here, whenever we paint one strip it is like here, and whenever we paint another strip above it, then it overlaps, right? So we have to tell which strip was painted last, right? And the constraint is that at least one strip is painted in the question, in the problem, right? So we just have to tell which strip was painted last, and you can see it in the example, even in this example, right? So the blue strip was painted first and then the red strip was painted. Since the red strip was painted afterwards, what happens is it just overlaps the blue strip, right? Now at the end we have to tell which strip was painted last. So let us see some more examples. As you can see, the answer for the third test case is blue. Why? Because you can see whenever we have a red strip and blue strips always overlaps it. So you can see it here and you can see it here and you can see it here, right? So a blue strips always overlaps it. So like one way to solve this problem is, let us assume that the red strip is painted last. So the red strip is painted last, right? So if the red strips are all, and the question mentions that the red strips are always painted in this manner, right? 1, 2, 3, 4, 1. Yeah, these are eight red characters. So they are always painted in a horizontal manner, right? From left to right. So if red strip was painted last, there must be at least one column where blue strip will overwrite it, right? So this would become blue and blue will go on like this. right? There will be at least one column. But if at any point, if at any row, all the characters are red, it means that the red strip was painted last. Red strip was painted last in the sense that the red strip was painted in the last row, right? So we just have to check if there exists even a single row where all the strips or all the characters in that row are red. So we can do it in this way, or we can just check if there exists even a single column in which all the characters are blue. So you can just check for either of those. So we were checking for red strip. So initially we assumed that the red strip was not painted last, right? And we go through all the rows. If either of the rows has all the 8 characters as red, that means that the red strip was painted last, right? So this is how we can form the solution, and this will always work, because even if the blue strip was painted last, then in one of the columns it has to be blue, and the blue will override it somewhere, right? And then the whole row will not be red. So this is the intuitive proof for this particular problem, and the code is very simple. You can just initially assume that the number of that the red strip was painted last. Red strip was not painted last. That is why I am initializing red with false. So I just run a loop from 0 to n, and I take I input a string s for all the rows, and I just run a loop for it. And whenever I encounter r, I increment the value of count r, right? I initialize it with 0 here. I increment the value of count r, and as soon as count r hits 8, that means that this particular row has all the red characters. I just mark my red as 1. So at the end I can just check if red is true, then the value answer would be r, otherwise the answer would be blue. So in this case we just have to check whether there is either one row that has all the characters equal to r. Similarly, you can do it for the column. In that case, you will have to check whether all the characters in that particular column is equals to blue or B. Then the answer would be B in that particular case, right? So this is the solution for the third question. Now moving on to the fourth question for today's contest. This particular question is coprime. So this question says that we have been given an array of n positive integers, and each value is from 1 to 1000. Now we have to find the maximum value of I plus j such that ai and aj are coprime, or -1 if no such I and j exists, right? So like this, the coprime means ai and aj should be coprime. It means that the GCD of ai and aj should be equal to 1, right? So this is our only question. So it says that the the value of n can be up to 2 into 10 to the power 5, but the value of ai itself is up to 1000. So we can just basically brute force through all the values of ai and check whether they are present in the array or not, right? For example, let me take an example, this particular thing. So if this is my question, I can just check whether 1 and 1, whether 1 and 1 are present in this particular array. If they are present, then it's if its GCD equals to 1, GCD of 1 comma 1 is 1, then I can just add its index. So in this case its index is 1, so the answer would be 2, right? Then I can check for 1 comma 2 if 1 and 2 are present. But if they are present, if their GCD is 1, GCD of 1 comma 2 is 1 comma 2 is 1, right? If they both are present, then I can just add their index 1 2 3 4, 4 plus 1 5. Then I can check for 1 comma 3, similarly for 1 comma 4, and up to 1 comma 1000, right? And then I will start for 2 comma 1. So this way I can just brute force through all the values of ai and aj which might be present in this particular array, right? If they are present, I also have to check whether their GCD is equals to 1. If they are present and their GCD is equals to 1, then I'll add the value of their indexes. Now there is one more thing that we need to mention, that is, for example, here 7 is present, but 7 actually has two indexes, 6 and 7, right? So obviously we would want to add the greatest value, that is 7 here. So we will always take the last occurrence of every element. The only index that we need to store is the last index of any particular element, so that when we compute the result or when we compute our answer, we get the maximum value, right? So let me just show you the code for this particular question. So I've taken a input in the number of integers given in my input, and I create two vectors. The first one is index and the second one is frequency, right? So I just like run a loop from 0 to less than n, and I take the input a. So as soon as I encounter a, I increment its frequency and I update the value of index of a is equals to I plus 1. So how am I storing the maximum value of index here? So if I'm running a loop from like 0 to less than n, the value of index of a would always be the maximum value of its index or its last index. For example, if I'm running a loop from left to right, when I commit 6, the value of 7 would become 6 plus 1, that is 7. The value of index of 7, right? That is 7. As soon as I reach this, so this would be 7. Actually, it should be in zero-based indexing. In my code, I have taken zero-based indexing. That is why I have incremented it by 1. So it would be like something like this. So it would be 5 plus 1, and it would be equal to 6, right? Then as soon as I move to the next index, the value of index at 7 would be updated by value of index of 7 would be updated by 6 plus 1, that is 7. So this way my this way index of a would always be the maximum value of index for the element a or the last occurrence of a, right? Now I initialize my answer with -1 and I just run a loop. So this loop can be written as, let me just write it properly, 1 less than 1001 I plus plus, and this can also be written as, right? So this is a simple for loop from 1 to less than 1001 or from 1 to 1000, right, to traverse all the values. So if f of I and f of j, it means that these values are non-zero or these are actually present in our initial given input array, and GCD of I and j is equals to 1. That means they are coprime. I'll set my answer as maximum of answer comma index of I plus index of j. So index of I would be containing the last occurrence of I or the greatest index of I. Similarly, index of j would be containing the last occurrence of j. I just sum it and I compare it with my answer. If it is greater, I update my answer. So after these two loops, I just print my answer at the end. So this was the solution for the fourth question. Now moving on to the fifth question for today's contest, which is Scuza. Now this particular question says that we have been given n steps and the ith step is ai meters high than its predecessor. The first step is a1 meters higher than the ground and the ground is at 0 meters. So we start at 0 and at each step we have to jump ai meters high, right? Now it says that like we have been given some values k1, k1, k2, k2 up to kq. So there will be k queries and each question should be answered independently. So what are those queries? It is stated that ki is equals to, like in the question it is stated, ki is the maximum possible height our character can jump or the maximum possible height that our character can climb, whatever you say, right? So if the value of ki is greater than or equal to aj, then he can climb that particular step, otherwise he cannot climb. So the value of aj, that is the height of this particular stair, should always be less than or equal to the maximum height our character can jump. So for example, if this is a ground at height 0 and the stairs are something like this. For example, this is a stair of height 1, this is a stair of height 10, this is a stair of height 5, right? And our character can go up to 8 height, right? He can jump a stair of maximum 8 height. So he can climb this particular stair because it is of height 1. Now when he comes to this stair, he cannot climb this particular stair because it is of height 2, it is of height 10, right, which is greater than the maximum possible height our character can jump or the character can climb. So he cannot climb this particular stair and he cannot move any further. So we just have to find the maximum height our character can climb. For example, if it was something like this, if it was 2, then 5 and then 3, right? The maximum height our character can climb is 8. So he can climb this particular stair, then this particular stair, then this particular stair. So at the end, he would have climbed 5 plus 2, 7, 7 plus 3, 10. So at the end, he would have climbed 10 meters or 10 any arbitrary value. Right. So the answer would be 10 in this case. So we just have to find the maximum height our character can climb. So if you carefully observe, then as soon as I encounter 10, which is a value greater than our permissible value, then we cannot move any further, right? So we can just basically calculate the prefix maximums of these values ai or the given input. So if I calculate the prefix maximum for the first input, that is 1, 10 and 5, I will have a vector like this. Or let me take an example from the sample test case. For example, if I take this, if this is my input, right? So the first stair is of height 1, then height 2, then height 1, then height 5. This is 1, this is 2, this is 1, and this is 5. Right? This is the ground which is at 0. So the prefix maximum would be 1, 2, 2, 5. Right? So why I am calculating the prefix maximum? Because if my character cannot cross this particular state, he will never reach this state. Right? If my character cannot cross this particular state, then he will never reach the state after it. Right? So I can just update the value of the next state as the previous value itself. Right? So that is why I am calculating prefix maximum. As soon as I have calculated the prefix maximums and I know that my character can climb x amount of height at each step, so I can just binary search the value of this particular x in this whole particular vector or in this whole particular array. So I encounter, so what do I have to search for? So for example, if this is any particular index I, so I just have to ensure that the prefix maximum which I have calculated, prefix maximum of I should be less than or equal to x. So this should be my condition, that the maximum height at the ith index till the ith index should be less than or equal to x. Then only I can climb up to here, otherwise I cannot climb up to here. If this is less than or equal to x, then I will search in the right half. If this is false, if this particular is false, that means if prefix maximum of I is greater than x, then I'll search in the left half. So in this case, I'll search in the right half. In this case, I'll search in the left half. I'll search for a smaller value. And now, as soon as I have encountered my position, as soon as I know that this is the position I'm going to go for, this is the maximum position I can go. So for example, if my character can climb only one stair, he can go up to this position only. If my character can climb 2 stairs, he can go up to this particular position. Right? If my character can climb 3 stairs, he can still go up to this particular position only. Right? So at this particular point, if I can go to the third index, then I can just output the value of prefix sums of all the values till here, right? So like for example, if I go to this particular state, or I can reach up to here, then the total height climbed would be 1 plus 2 plus 2, that is equal to 5. So I can just store the values in the prefix sum and output it in O of 1 time. So this is exactly what we will do, and we have to pre-compute 2 of those things, which is the first one is prefix max. That is, so the prefix max stores that the maximum value till the ith index, and the prefix sum will obviously store the prefix sums, which is like the sum of all the elements from 0 to I, right? And so this is like this is my input. I have taken 2 integers n and q, and I have taken input in it. Now I initialize my vector of size n plus 1 and I take input in it. Now I've created 2 vectors pre and max. So pre is storing prefix sums and max is storing prefix maximums. Right. Now I just update the value of both of the vectors, pre and max. So pre of I would be pre of I minus 1 plus p of I, and max of I would be maximum of max of I minus 1 comma v of I. So this way I update both the arrays. Now I just input the k of those queries, and I just check each of these. So check is the variable. That means I have to check for this particular value. So if this variable is even smaller than the first climb, rather than the first stair, right, then the answer would obviously be 0 because he cannot even climb even a single stair. Now, if this is not the case, if this is the case, I just print 0 and just continue for the next query. If this is not the case, I take two variables L and low and L and H, which is basically low and high. So this stands for low and this stands for high. So I know I am going to this is always true, this is always false. So for binary search, I am going to maintain this invariance that the value of max of L will always be true, because I can always climb up to this particular stair at least, and the value of this the value of at index H will always be false, because I cannot climb n plus 1 stair, because there is no such stair. So I am going to maintain this particular invariance and I calculate the value of mid for each of these. Now if max of mid is less than equal to check, then I am going to search in the right half. That is why I update my L is equals to mid. Otherwise, I am going to search in the left half. That is why I am updating my H is equals to mid. Now at the end, L was always true. So I just print the value of pre of L, which is my prefix sums. Right. So in this way, I can print all the values, and at the end, I can just print a new line. So this would be my solution for the fifth question. Now moving on to the last question for today's contest. That was Orray. So this was basically OR plus array. So I believe this is what they wanted it to be. So they wanted to make it something like this. So they came up with, so the problem setters came up with this unique name Orray. So we are going to solve this problem, and this states that we have been given an array consisting of n non-negative integers, and they have defined prefix or array B as the array B of I is equals to A1 or A2 or A3 up to A of I. So this particular question basically states that the prefix or array would be like prefix or at I would be A1 or A2 or A3 up to AI, right? So we have to arrange the elements of the initial array A such that this particular array is lexigraphically maximum. Lexigraphically maximum means that the sequence pre of I, pre of 0, then pre of 1, then pre of 2, then this particular sequence should be as bigger as possible or the maximum possible, right? So this is our question. So for example, let me just show you an example. We'll take this particular test case. So if we take this particular element 5, then we will have something like this. So this is the 5 in binary, that is 101. Now so after taking it, the value of prefix OR would be 5, right? What should I take the next value such that the prefix OR is maximized, right? So till now you must have observed that taking the maximum value is not always feasible, because if I take the maximum value after 5, that is 4, then the value of prefix OR would be still 101. That is not what we want, right? We want to increase the value of prefix OR. So the next suitable value in this particular case would be 2. If I take 2, then the prefix OR would be something like this. That would be 7, right? So if you see the example in this case, after 5 they have taken 2. This is why they have taken 2, because if I OR the 5 and 2, then I'll get 7. So this way I can maximize the value of this way I can make the prefix OR array lexigraphically maximum. So right now, a general idea for this particular question is, for example, if I have some values, if I have my required number, so let me just take some arbitrary number of bits. Right now I'm not counting it, but let's say we have these bits. So 0, 1, 2, 3, 4, 5, 6. Let's assume we have these 8 bits, right? So now if I want to maximize my or make the prefix or array lexicographically maximum, then obviously I would want my first element to be the largest possible, right? Or if I start traversing from here, if I traverse from left to right, I would want the element which has the maximum this left bit set, right? Now there might be certain elements. For example, there might be an element like this, right? And there might be an element like this, right? So if I take this one and if I take this one, let us assume two different cases. Then the value of pre of 0 in the first case would be 0 0 0 0, some number of zeros, and in the second case it would be then 1 1, then some number of zeros, right? So obviously it is better to take the second element here, right? But what if after we take the second element? Once we take the second element, then the prefix value of prefix pre of 0 would be something like this, right? This is the value of pre of 0. Now in the rest of the elements, no matter how many elements have these two bits set, if any of those elements have these two bits set and I take them, for example, if there was an element like this and I take it, my value of prefix of 1 would never change, right? If I take the next element like this, my value of pre of 1 would not change because this particular bit was already taken in pre of 0, right? So obviously I would want to look for a bit which does not have this particular value, right? Which does not have this bit set, or even if it has this bit set, I would want the rest of the bits to be maximum. So it can be something like this, right? Or something like this. I don't care about these two bits anymore because I already have them set in my answer. But what I do care about is these bits which are remaining, which were 0 earlier, right? So the question is, how do we find this, right? So once I have the initial answer. So let us take a smaller example now. Let us take some less number of bits. So if there are 4 bits and I've taken my first number as like this. So after I've taken this, I can just XOR these two values and I'll get the result as 0 1 1 1. So this is what I'm looking for now. So this is what I'm looking for now, right? This is what I want, but I might or might not get an exact match, right? So what I do is I traverse through all the values and I just take the AND of it with this particular value. Why I'm taking the AND of it? So for example, if I have some value 1 1 1 1 1 and I want 0 1 1 1, I can create a submask of this particular value. So after creating a submask, the answer would be 1 1 1 0 1 1, right? If my second value was something like this, my submask would look like this, right? So I can just create a submask and then I can find the maximum value which is adding the most number of bits to my answer, right? So for example, after taking this particular value initially, I want to after taking this particular value initially, I have marked this particular bit as 0 and all the others are 1. Now I want to find the maximum value which can contribute the most to my answer. So for that, I will create a submask of this particular value with all the values. So after creating a submask, all the other the values in the in the given input would look something like this, right? So for example, these are the 3 values after taking the submask, right? So out of these 3 values, this is the maximum value that is contributing the most, because these 2 bits I want them to be set. They are not currently set in my answer, and this is the max. This is the value that is giving the maximum contribution. So I can take this particular value and include it in my answer. Once I include it in my answer, then I'll update my required array as the XOR of 0 1 1 0, and it would be updated as like this, right? So now I need this particular value more, because this is the only bit that is not set in my answer. All the other bits have already been set in my answer, right? So if I want this particular value, and even if I had this, or if I had this or any bigger value, right, they would be of no use, because these bits, like this particular bit, this particular bit, this particular bit, they are already set in my answer. Even if I take them, they would result in no change. So I want to find this particular value in the remaining values, or like even this would work. This value would work for this case, because after I take my submask, like if I do and of this, I would be left with only 0001. So this would satisfy my requirement and I can update it. So basically what I have to do is, initially I set my requirement as some bigger number, right? So this is my requirement, let's say, right? Now I create a submask with all the values and I find the maximum of them. So for example, I found some value which was the maximum among them, like this. So this was the maximum value I found. I can just take a XOR of these value, or XOR of this value with the required value. So the resultant value would be something like this, right? Oh, sorry. So the resultant value would be something like this, right? So this is the new value that I require. Why this is the new value that I require? Because these two bits are now set. Even if they are present in any other value, I don't care, because this would not help me increase my answer, right? So now again I will search for other values, taking this particular requirement as a mask, and after I create a submask, I'll search for the maximum among them. So now let me just directly show you the code so it is more clear how it is working. So initially I just take an input n, the number of integers, and I create a map of integers, right? So this would basically store the frequency of all the characters. After I have taken the input in a map, I just initialize my required value as 0. So initially I am just taking it to be 2 raised to the power 30 minus 1. So the input values of AI was up to 10 raised to the power 9. So I thought 30 bits or 2 raised to the power 30 minus 1 would be an apt required value, because this would be greater than all the values present in the input, right? So I just create my answer vector, and so initially it is an empty vector, and I run a loop from 0 to less than n, minimum of 40 and n. So why taking this particular value 40? It would have also worked with 30, right? 30 would also work, but the logic behind taking this value is, so why would I take 30? Why would I take 30 loops here? So for example, if there were 30 bits, let us take a smaller example. Let us say there are only 4 bits, right? So the maximum number of steps to cover all the bits would be 4. Why? Because for example, in the first case I got this number, then in the second case I got this number, in the third case I got this number, and the fourth case I got this number, right? So the maximum number of steps to cover all the bits in any case would be equal to the number of bits present in my in the number of bits I had taken initially, right? So in this case it was 4, and in this case it can be 30. So I just took an arbitrary value greater than 30, which was 40 in this case. But taking this particular value was the main logic, that it should be at least equal to 30, right? So that even if each time even a single bit is satisfied, then at the end, after taking 30 bits, all of the values would be 1, and no matter in what order I arrange the rest of the values, the answer would always be the same. So once I reach this particular value, no matter what values are after it, the answer would always be the same, right? So, and if the number of elements in the given input is less than 40 or 30, then I will run my loop up to that particular element, right? So I'm initializing a variable take. So this is the element. This is the element I want to take, right? And this is the maximum contribution by any element. So what I do is I just take any arbitrary value which is present in the starting of my map, and I take this particular value, and this is the element I want to take at the end, right? Let us start with the first value itself. Now this is the maximum contribution by any element. So if I take that particular element and create a submask with required, then this would be the maximum contribution to it, right? Now I just traverse through the map, and if the value of it.first and required It means that the current element which I am like looking at, if its contribution is greater than the maximum contribution, I'll update the maximum contribution and just take it and just mark it as take. So I am updating this value. So updating maximum contribution and updating the value of take. So I am going to take this particular variable now. Now after I traverse through all the values, I found my best answer which is stored in take. So I just push back it in my answer, and I XOR the value of next with the required, so that I do not have to consider the bits which are being contributed by the current element. So here, for example, when we were taking XOR, so initially these bits were required, but as soon as I got these particular bits, I take XOR so that next time they are set as 0 and I don't have to worry about them, right? So that is why I'm taking XOR with next. Now in the next step, I just decrement the frequency of the element I have taken, and if the element is now present 0 times, so I just remove it from the map, right? And now at the end, I just take all the remaining elements. So no matter in what order they are present, I can just store them in any order. So for all the remaining elements, I just push them in my vector and I decrement their frequency by 1. At the end, I'll just print my answer vector. So this was the solution for the last question for today's contest. And I hope you guys were able to understand the solutions. So till the next video drops, keep coding, stay safe, bye bye.